All right, good morning, students. So today we are going to learn about specific latent heat. By the end of this lesson, I want you to be able to describe energy changes during melting and vaporization. You should be able to calculate the latent heat of fusion and latent heat of vaporization for a substance. And you should be able to combine a variety of equations to solve problems involving heating. For the starter activity, I want you to take some time and do this code breaker activity and try to find out the blanks. You can pause the video and then you can find out the statement. Right, welcome back. You can see this is the answer. Internal energy is the total amount of kinetic and potential energy of all the particles in the substance. This is what we have done in lesson number 4 last time. So according to the bigger picture, we are on lesson number 5 today of topic P6, molecules and matter, and the title for today's lesson is specific latent heat. So if you look into this graph, you can see along x-axis we have time and along y-axis we have temperature. So when the time increases, the temperature is increasing, but at some certain point at this part, where we can see melting and freezing, the temperature is remaining constant here and temperature is constant here. Temperature is not increasing. If we are giving up the thermal heat energy to the system, but the temperature is not increasing, so what's the reason behind it? This is very important to understand. You can see into the picture, at first it is solid and then liquid and then this is gas. So states are changing by absorbing the heat energy, and we can see temperature is increasing and then gets stationary, constant. Temperature is not changing here, and then temperature start increasing and then constant. So what's the reason behind it that temperature start changing and then stop changing and then temperature start increasing and then stop changing? This is what we are going to learn. So at the beginning, when the temperature is increasing, it means particles are absorbing heat. Okay, and when the state changes from solid to liquid, then particles are using that heat energy in changing state. So that's why temperature is not increasing. Temperature get constant, but it doesn't mean like heat energy is not given. So that's what the energy is being used. This is what we call latent heat. If you see the dictionary, the meaning of latent means something hidden, something which is not manifested, which is not developed yet. So heat is there, but temperature is not increasing because that heat is being used in changing state. And if you see on the second gradient where it has been changed into the liquids, and now the particles are in liquid state, and temperature is increasing, but suddenly again there is a straight constant line when temperature is not increasing here. So when temperature is not increasing again, this is a latent heat where the state is going to be changed from liquid to gas. So when all the particles change its states, then again temperature start increasing and we got another gradient. So here is the definition of latent heat. So you can see latent heat is the amount of heat energy transferred to the substance when it changes state. So when we got the straight line here and here, then we can see at 0 degree temperature, there is a no change in temperature, and at 100 degree, there is a constant temperature for some time. For a couple of seconds, you can see it means there is a position when the state is changing and the temperature doesn't change because that heat is being used, it's being transferred to the substance or particles. So the amount of energy transferred during these bits, okay, that's why temperature doesn't increase. So here is a definition of specific latent heat. When we talk about latent heat, we talk about in general, but when we talk about specific latent heat, we talk about a specific amount, specific mass. So specific latent heat is the amount of heat energy required to change the state of 1 kilogram of substance. So when we talk about a particular mass, then we call this specific latent heat. Now, there are two types of specific latent heat because there is a state changing. So specific latent heat of fusion and specific latent heat of vaporization. So when solid changes into the liquid, then we call that specific latent heat of fusion. And when liquid changes to a gas, then we call that specific latent heat of vaporization. So specific latent heat of fusion tends to be significantly lower than the specific latent heat of vaporization. We have seen this into the graph before on the previous slide as well. You can see the table here and you can compare. This is a fact that specific latent heat of vaporization is slightly higher than the specific latent heat of fusion. So here is the equation for specific latent heat, that is energy divided by mass. This is the triangle by which you can learn how to rearrange the equation for different values. So both fusion and vaporization have the same equation with the small difference. So specific latent heat of fusion will be LF and specific latent heat of vaporization will be LV. Here are some examples. By using this equation, can you find out the amount of heat, and in the second question you can find out the mass. So pause this video and do your calculations and come up with your answers. Good, welcome back. So you can see your answers. First of all, you write down the equation, rearrange it, and then you put your values and make sure you put the correct units. For second question, you rearrange equation according to your requirements. You have to calculate mass here, and then you calculate accordingly and you put the correct units. Here is a mistake, so it should be mass. It shouldn't be E. Sorry about that. Right, so here is the exam questions based on calculations. So you can pause the video and then you can do your calculations. Okay, welcome back, and here are your answers. You can mark up your answers.